Hello and welcome back, and let's see two more questions today. We will practice two more questions. One is like print the type of values an array is storing, and the second one is an exercise. We have to create a 2D matrix, two-dimensional matrix basically. Matrix is always a two-dimensional, so we have to create a two-dimensional array basically to represent a matrix, and we have to find if this matrix is an identity matrix or not. Right, so what is an identity matrix and what are those things we are going to discuss. And let me start the first exercise. So first one is print the type of values an array is storing. So I'm just going to import numpy as np, and then I'm just going to do this. I'm just going to create an array is equal to np dot array, and then I'm going to put something like 12, 14, 16, 89, and I'm going to store these as an array and giving the input as the list. So this is the list where I have created, and now I'm going to print the type. So d type is the thing which is used, is the property which is used to find out what type of array it is. I mean, what kind of values this array is storing. So let me run it and let's see what comes out to be. So it comes out to be int 32. So all these values are integers, so that's why it has shown me int 32. So based on the d type, you can find out what kind of values this is storing. Okay. Now let's go to the second exercise. And before that, let me do one more thing for you. If you want to convert it into another type of array, like into a string kind of array, then what you will do, this will be a revision of the previous exercise which we have done in the previous video. So I hope you might be aware like what we need to do. So you can stop this video and for a while, and then you can check what you will do to convert this particular array into an array of the strings, right? So you can stop if you want, otherwise let's see what we will do. So I'm just going to create array2 is equal to array1 dot as type, and I'm just going to convert it into the string. So this will be converted into a string, and now if I print arr2, then it should print the entire array in the form of, okay, arr2, arr1 is not defined, it's array, okay, not arr1. So let me run it. So now you can see it has been converted into the string. Every value in this array has been converted now into the separate string. So this is the representation. B will be written in the beginning, so it doesn't mean anything like binary. It's simply like a representation. It's a byte for the character arrays. It's a byte for the character arrays 14, 16, and 89. So this is how you can convert it into the string. Okay, so this is what is known as the conversion from one type to the other. And let me tell you that array.as type doesn't convert the original array itself into the different type. It returns an array of a different type of values with those values, right? So array2 contains all the different type of values, and they will be stored in array2 from array1. From array. So now if you try to see this, then you can see that array, if I print array, then it's still the integer array. It's not the string array. If I put like array2, then only I will be able to see all the string values. So this was just the repetition of the previous exercise that we did. And now let me try something else, which is the next question from our site, which is create a two-dimensional array. Basically, it should be two-dimensional array. Find the row and column count using the appropriate functions. We need to find out the row and column count using the appropriate functions, and then find if the matrix is an identity matrix. We have to find out if this matrix, if this two-dimensional array is a identity matrix. So for the identity matrix, we have to create a two-dimensional array in such a way so that the number of rows and columns are equal. They should not be different. It can be 3 cross 3, it can be 2 cross 2, it can be 4 cross 4, but it cannot be like 2 cross 4, 3 cross 4, something like that. It should be kind of matrix which has equal number of columns and equal number of rows, right? Number of rows and columns equal basically. So let me write that. So let me remove this particular section, and now let me import numpy as np, and then I'm just going to create an array, or you can say the matrix is equal to np dot array. And if you have to create the two-dimensional array, then you have to do something like this. In the first one I'm just putting 1 0 0, and then in the second one I'm putting like 0 1 0, something like this, and then I'm putting 0 0 and 1, right? So you need to put these rows basically inside another list, right? So you can see I've just not used like I have given the commas and just placed them. I have placed them inside a list, all these rows 1 0 0, the second row 0 1 0, and the third row 0 0 1. All these I have put inside a bracket, right? This kind of bracket which is used for the list. And now I'm just going to give like d type is equal to integer 4 bytes in 32. So this is how it will create the matrix, and now let us print it. Print matrix. So if I print this matrix, okay, matrix is okay, maxtrix, it has become maxtrix. Let me make it matrix. So this is a kind of matrix where diagonally every element is 1, but all the other elements apart from the diagonal elements are 0. Such kind of matrix are known as the identity matrix. Why these are known as the identity matrix? Because when you multiply this this matrix with any of the matrix, then the matrix value doesn't change. So if you take any of the matrix and then you apply the multiplication operation on this one with this one, then you will be able to get the same matrix again, which means that if you do like a into I, so if I represents the identity matrix and A represents the original matrix, then the output will be A, right? Which means nothing will change inside A as a result of multiplication, right? So such kind of matrices are known as the identity matrices, right? This is multiplicative identity matrix. And what about the additive identity? For the additive identity, all the elements in this two-dimensional array in this matrix should be 0. So if all the elements are 0, then it will be additive identity, which means after addition to any of the matrix value will not change, right? So that will be the additive identity, but that is not used anywhere. Any such application is not there. But this identity, which is known as the multiplicative identity, this is very much useful, because this is used to find out the values of the variables when you are using some equation, like equations with the 3 variables, x plus y plus z is equal to 1, something like that. You create the set of equations where 3 variables are there, three unknowns are there, and you get some equations, and based on those equations you create a matrix. And if you follow that, and if you multiply that matrix and you convert the matrix, and you take the transpose of the matrix, you take the inverse of the matrix, you take the adjoint of the matrix, then after that if you do the identity multiplication with the original matrix and you solve both sides, then you get the original values for the variables like x, y and z. That is pure mathematics that I'm not going to tell you here. If you are aware about these things, if you have studied mathematics in your school days, and if you have studied about the matrices, then you would be able to correlate this thing what I was talking about. But that is not the purpose of this video, right? If you are not able to understand that, then doesn't need to worry about it. It was not the purpose of this particular video and this particular course. The mathematical portion I will try to cover in the other videos and the other playlist, so that will be a separate thing, right? So I'm not basically it's not like I'm a machine learning expert, but yeah, what machine learning demands, all those things whatever I have studied, I'm trying to explain it here. And basically Numpy, I have studied it because for the other things as well, because this is a very useful library to perform the mathematical matrix operations. So that is why I studied this one. Not only this one, the Panda, the scikit-learn, they are all very rich Python libraries. So we are going to discuss all of them in the separate videos, in separate playlists only. Okay, so we have written this we have printed this matrix. Now we have to find out if someone gives me that whether this matrix is a complete matrix or not, I mean identity matrix or not. Then what I will do, someone has given me a matrix and I want to find out if that matrix is an identity matrix or not. So what I will do, so for that I think we can do in this video itself. So what I will do after printing the matrix, I need to start iterating through the matrix. So if you have to iterate through the matrix, suppose this is the matrix, the two-dimensional matrix, and I want to print this two-dimensional matrix using the for loop. I want to iterate through the for loop. Then what I need to do, for I in matrix. So when I will do this for I in matrix, then in that case what will happen, that all the rows will come into I, right? It will collect all the information in the row basis, right? This I will contain separate rows. Now when I will start for j in I, now inside the I, which means inside the rows, I want to iterate through the elements. So I will reach out to the individual elements inside the inside the rows. So now if I print it, print, and if I print like j, and then I put like end is equal to /t, which means that I want to end my line not with the new line but with the /t, which means the tab, right? So now this has been done, and after every line will be printed, I would like to move to the next line. So I would like to do something like this, print /n. So after all the values in a matrix row has been printed, after that I will move to the next line. Before that I will be doing the tab, right? And this will be the thing that will help me to print all the things. So let me run it again. So now you can see, let me just remove this line so that I can print the matrix through my code. So 1 0 0 0 1 0 0 0 1. So this is the way I can iterate through the matrix. You can iterate through the individual elements as well. If you have to iterate through the individual elements, if you have to reach out to the individual element, you can use the same type of array indexing that you have used in different programming languages. So let me do that one as well. So this was one of the ways to iterate through the elements. If you are very much interested only in the values and you don't have to perform the operation at a particular index, then you can follow this method. Now I want to iterate through the iterate through the elements, each of the elements at a particular index in this two-dimensional array, which is a matrix. Then in that case what I will do, I need to first find out the number of rows and columns, right? So to find out the number of rows and columns, I can take two variables, rows, row and col. Okay, then I need to use matrix dot size. If I use this method, then the rows and columns can be printed. Print row, and then on the next line I'm printing the column. So matrix dot it's not size, it's shape. Tuple object is not callable. So this is row and column. Okay, so you don't I was doing a mistake. It was not a function, it's a property. So it's basically an attribute of this array object. So matrix dot shape, it will return a tuple. Basically it is returning a tuple of two values. One is the number of rows and the other is the number of columns. If it was a three-dimensional matrix, then it will return three values, the three dimensions, right? So it is a two-dimensional array, so that is why it is only returning the two values, which is the number of rows and the number of columns. So the shape function, shape attribute, you can use to find out the number of rows and columns or the dimensions of the matrix, right? I have printed this, so this is 3 and 3. So row contains 3 and column also contains 3. Now I would like to iterate through the same array using the indexing, right? So I have to do this something like this, for I in range 0 till row, right? I hope you are aware about this range function. I'm not going to explain this. just to make a summary of this range function, it will start from 0 index and it will go till row -1 the maximum number, right? So it will go from 0 to 2, right? So because row is 3, right? So now I'm just going to do for j in range 0 to column, right? So now I'm just going to print using the indexing. I'm just going to print the values using the index, right? So what I will do, print, I will do matrix, and then I will do I and j, and then at the end I would like to add the /t, which means the tab, because if you will not give this, by default it will move to the next line. I want to print all the values in a row, in a line spaced with the tab, and rest of the values after one row is completed I would like to move to the next line. So what I will do now, I will write print /n. Now let us print it again and let us see what comes up. So this is the way it is again printed. So you can use this one as well, right? And you can use the other method as well, but this indexing method is really useful. If you use this indexing method, then in that case you will be able to perform some easy operations on your piece of code. So if you want to write this code, if you want to see this code again, how this code can be written, you can stop the videos, because I'm not going to share this piece of code with you. I'm just writing it in front of you just to explain you, and you should try it yourself, and you can write it yourself, right? So this is the one, and our target to access the elements in an array using the indexing, that has been done. And in this question itself, I would like to put these questions in front of you in the description section. So create a two-dimensional array, find the row and column, and then find the matrix. You can, as this instruction as well, use the indexing as well to iterate through the elements of the array. So this is only one exercise, creating a 2D array and iterating through it, but this one exercise will help you to practice 2 or 3 things at the same time. Iterating through the for loop, iterating through the indexes, all these things you will be able to practice. So that is why this is really a useful set of questions for you. And I assure you that if you follow these questions and if you keep doing the practice of all these questions time to time, your Numpy library will be very strong, right? Now let us do our logic. What logic I need to perform? I have to find out whether the matrix is an identity matrix or not. So what I will do, I will create a flag here, b flag is equal to true, right? I have created a flag with value true, and now what I will do, if matrix, if I is equal to j, which means if the row is equal to column number, right, then the value should be 0. If I is equal to j, then if matrix I is not equal to, matrix I j is not equal to 0, then we need to break it. We cannot move ahead, and before breaking we need to set b flag as equal to false. We need to do this. This is the first condition. The other condition is, if the other condition is here, right, this if. So if I do write like else, and if I write like if matrix, else means when the row number is not equal to column number. When the row number is not equal to column number, in that case the value should not be 1 or anything else. It should be 0. Apart from number of rows and columns where they are equal, every value should be 0. Where the row and column are equal, row number and the column number are equal, only that place it should be 1. Then it will be an identity matrix. So first condition we have written. The second condition, when the I is not equal to 0, then matrix I and j, if that is not equal to, right, here it should be 1, sorry, here it should be 0. When the row and column are equal, I and j both are equal, then it should be having the value 1. And if both are not equal, then in that case, if it is not 0, because it should be 0, if it is not 0, then we will make flag is equal to false. Right? So I hope this logic is very simple and you are able to understand this, understand it. So let me now put our logic. If b flag is equal to true, then I will print that the value whether this matrix is an identity matrix. The matrix is an identity matrix, else print the matrix is not an identity matrix. Okay, so these are the two things. Now let me run it. Right, I was printing it. Now it will not print, it will only print whether the matrix is an identity matrix or not. So let me reiterate it again. If the I and j, I have started iterating through the indexes. So I have taken the row and columns values using the shape value. It returns using the shape attribute, it returns a tuple. So if it returns a tuple, so whatever number of values it is returning inside a tuple, those number of variables you can take separated by comma, and all those values will be taken here. So number of rows and columns, they are all here, right? So all the dimensions have been given to you. Now I have iterated through the rows and then iterated through the columns, right? And I have iterated through the indexes. So row and column index. If the I and j, which means the row and column, this is the 0th row. If you see this one, 0th row, 0th column, this is first row, first column, this is second row, second column, because the indexing is starting at 0th index, right? So when the row and columns are equal, then only the value should be 1. If the value is not 1, then we have to break it. Here also you need to break it. We have to break it and we have to make a flag as false. Earlier we have set it true. So if we doesn't meet this condition, any of these conditions, then it means that everything was fine as per the logic, and this was an identity matrix, right? So this is the logic that you need to apply. And now let me run it. So you can see the matrix is an identity matrix. This has been printed because this matrix is an identity matrix. Now let me put some other values here. If I put like 1, if I make this original array, original matrix, the second row I make it 1 for the last element, then what will happen? The matrix is not an identity matrix. So this is working fine. Now let me put it like 0, 0, 1. If I do this, then also this matrix is not an identity matrix, right? So 0, 1, 0, this is an identity matrix, and I have created the logic for this. 1, 0, 0, 0, 1, 0, 0, 0, 1, this is an identity matrix. So this will be printed again as an identity matrix. So that's all about this particular video, and these two questions I will provide you in the description section, and you can keep these exercises practicing. Have a nice day and bye bye.